I probably am at the point where there's more people that don't know me in this room than that do know me, which is, I don't know, a little bit interesting after, being here for 26 years like I have been. I started out with Marathon in 1999 here in Oklahoma City, then moved over to EOG, was there for a number of years, went over to Devon in 2011. They asked me to leave in 2019, and I went to EnerQuest Oil and Gas and was there for a number of years, and then had to part ways with them. And most of you know Matt. I mean, Matt's one of the nicest guys you ever met in the world, and he didn't want to do it, but just the way it is when you're at a small company. But after that, of course, you always wonder when you're in between jobs and layoffs and stuff, and you're like, hey, I've been doing something the same for 25 years. Do I make a change? Do I keep going? Do you try to spin yourself out of this crazy oil and gas business that frustrates most of us more days than not? But a funny thing happened on the way to finding my new job is I figured out a way to basically still use my skill set, but be out of the oil and gas industry as far as the hydrocarbon side goes. Because everything I do is the same thing I've done for 26 years in oil and gas. It's just a different product. That's really the only difference. So I'm Brad Cage. I'm the Vice President of Engineering for Pulsar Helium. We started 3 years ago, roughly, but in 2023 officially. Our primary holdings right now are in northern Minnesota in Lake County, far away from what's going on in the Twin Cities at the moment. And we also are about to acquire acreage somewhere else. It's not, I don't think it's 100% official yet, so I can't completely say it. But we also have a project in Greenland that we're working on, which is going to take a little bit more time, just because you're dealing with the Danish government and the Greenland government. Of course, I mean, maybe the US government here is pretty soon, depending on what Trump does. But you never know. But that's a completely different project. I'll go into some details on that. I don't remember if there's a slide in here on that one or not, but it's basically, it's two different types of projects. Because the primary one we're doing in Minnesota is basically what you guys and gals are all used to, just traditional drilling for oil, for gas. Process is still the same, nothing different. The Greenland project is going to involve drilling wells and doing some geothermal and hydrogen or helium separation from water. So anyway, so I'll get going so we can get out of here. Here's the normal, usual slide on, here's what we do and all the forward-looking disclaimers and all that stuff. So go that. So basically what you're dealing with is you have a product right now that is in high demand in helium, and it's getting even in higher demand. It's going to keep going up with what's going on as far as its uses, mainly in semiconductor processing. That's probably one of the big ones. And I'll go, there's a slide here on a lot of the uses for it going forward. But like everything else, production is declining on this. And because primarily it's really been an extract out of most hydrocarbon plays. People have finally started looking primarily just for helium plays in systems that are a little more friendly as far as separation and processing of it. Of course, Russia promised that they were going to have a bunch of helium come out of their new big gas plant that they opened and started up a couple years ago, and they're about half of what they expected. So you've got demand worldwide that's going to just keep going up. And I think Amarillo, which is where our storage has been for years in the United States, there's things going on there where they're talking about shutting that down or not maintaining it the way that they were. And so the question is, moving forward, where are we going to get this stuff from? Where are we going to find it and develop it? And right now, honestly, from a price standpoint, I feel bad for you guys. But it's really, really up there when you're talking that basically, a cube of helium will sit on a location is basically worth $1 million in liquefied form, which is the preferred transport method if you can get there, because the problem with helium molecules, if you all remember back from chemistry, they're really, really tiny. So keeping them in a gaseous state and completely contained is tough. You basically have about a 30 to 40 day life on when you can get it out and get it somewhere and get it to an end user. So our mission right now is, can we deliver a stable source of helium to the world? Pulsar Helium is an international company. We have our headquarters in Portugal. We have an office in Canada, and we have a doing business as entity in the United States known as Keewatin. More than likely, that will switch to an actual U.S. entity probably this year, maybe next year, depending on how that will all go through. But of course, like anything else, how can you do this low cost? Where can you find it and get it moving? Because here's what you need it for. Yes, I mean, obviously there's balloons, and everyone gives me that joke when we talk about helium, but you're really looking at the chip manufacturing. Like I said, it is probably, no, it is right now the best cooling fluid for semiconductor processing. They've tried nitrogen, they've tried CO2, they've tried other ones, and nothing is as efficient as helium right now. And we all know that more and more, everything's getting a computer chip put in it. That's going to go even higher as far as that processing right now. And so there's going to need more and more to get just that process going. Yes, we have talked to SpaceX. Musk is interested in any helium source that's out there. Nothing official yet, because obviously we're still kind of in development and exploration phase at this point, but that's going to be one of those avenues that will be a market that's open to us. It's huge in the medical industry, MRIs, other things like that. And one thing that a lot of people don't realize, inhalers. A tiny amount of every inhaler has helium in it. And so that's another huge end user market that we're looking at supplying for. And then, you know, all the quantum computing and things like that. And then the other thing too is lasers at the stores for barcodes and everything. One of the components in there is helium as far as the lasers go. So there's a ton of markets that this is used for and used in, and most of them are at the point where they're growing right now. So some highlights from the last couple of years that Pulsar has been around. We have flowed 2 wells in way northern Minnesota. See, where's my laser on here? There it is. So we're up here, and that's north of Duluth. So it is not a friendly condition because you're basically winter for 8 months out of the year. There's a lot of stuff you have to do in frozen conditions, but it's workable. I mean, we've all dealt with stuff like this before. We deal in frozen conditions in Canada and the Rockies, stuff like that. But so it's nothing at least that is new to the industry as far as dealing with it. But anyway, so we drilled 2 wells. We drilled the Jetstream 1 in 2024. That's how I originally got involved with Pulsar. They needed someone to do a well test analysis on the well. Then we followed it up where we deepened the Jetstream 1 in early 2025 and drilled the Jetstream 2 as well. Both of those wells were tested. The Jetstream 1 had an average concentration of helium at 8%, and the Jetstream 2 is about 5.5. And for the most part, economic conditions are, what you can see, 0.3 to 1% is economic. So we're well north of economic conditions for our products. Plus, we don't have to deal with hydrocarbons as far as the separation, which I'll get into in a little bit. We do have one of the highest helium-3 contents announced ever publicly on a land-based project. We're at 11 parts per billion. Now the trick will be, can you actually separate helium-3 from helium-4? That right now is a process that is still developing and is not currently economically feasible, but it's one of those, if you can figure it out, it's highly valuable, highly sought after, and you don't have to go to nuclear power plants to get it. But we're probably, I mean, we're a step away technology-wise from actually that being able to separate that out. But there's plenty of markets for helium-4, so that's not the issue. As I talked about, there's a huge price upside right now and a supply that is really getting strained in the markets. And right for the company-wide, right now, we hold 15% equity of the company. We are fully publicly traded. We have no private equity and no venture capital inside the company right now. We're really trying to avoid that because most of you have dealt with some PE firms before, knows what that can get into and some of the strings that get attached. So we're publicly traded we're over the counter in the US, and then we're listed in Canada and in the United Kingdom. So this gets into a little bit about helium-3 again. We're working with the Department of Energy and NASA as well to try to couple with them and see what they can help us out with as far as research and things like that. But the big thing is that, you know, the real use that more so than, you know, fusion and the neutron detection, the biggest thing is the quantum computing piece. If you can unlock helium-3 for the quantum computing side, that's going to be a game changer on that side because it's way more efficient than what we're using right now, which is regular helium. But like I said, unfortunately, we're a technological generation away from that probably being a reality, but it's still something to keep moving towards. So to give you an idea of, like I said, we're here in northern Minnesota. This is our Topaz project, which is on the Bald Eagle intrusion. And for those of you who are unfamiliar with this area geologically, this is on the failed rift that happened. It goes into Canada, down into Minnesota, down through Iowa, all the way down to Nebraska. So this is a failed tectonic plate that I can't remember how many millions of years ago didn't completely form. And so the reason you have helium and hydrogen here is because of that. You're dealing with volcanics. You're not dealing with what all the rest of us have been used to for years in the oil and gas industry, where you've got sediment deposits and basins and high organic material that comes in there and forms hydrocarbons. All of that's gone. You had volcanics, high heat, lava, so you're dealing with uranium decay and things like that, which is why you end up with the gases that you have here and basically no oil, no natural gas whatsoever. You end up with the helium and the hydrogen because what we're dealing with is igneous rocks too. Not shales, not sandstones, not carbonates, it's igneous. And it is really tough to drill and has like no porosity. But it's highly fractured because of all of the geologic tectonics and everything else that happened in this area. That's why all this stuff is trapped. That's why all this stuff was formed. And so we're producing through complete natural fractures, not through matrix at all. Now, there's some thought, and we're getting high-res micro-CT on our rocks. We think there might be a micro porosity and a fracture porosity component to this, but we're still in the initial testing and evaluation of that going forward, which if that happens, then you've got a resource estimate that goes even higher than what we're looking at right now. But anyway, we are on our 5th well right now. The first 2 we drilled conventionally with a rig and an air package on both of those. And then we switched over to using a mineral coring rig, which are used quite frequently all throughout Minnesota, in the Dakotas, Canada, and even in the Upper Peninsula in Michigan, because they've been there for years looking for, it's mining country, so looking for iron deposits, nickel deposits, things like that. We needed the core material, but surprisingly, it has been much more efficient than we expected coring 3,000 feet. We air drill the wells in probably 20 to 25 days, going down to roughly 5,000 feet. But right now we're coring these things in about 20 days down to 3,000 feet, and it's a third of the cost, even with that slower penetration rate and everything. But we need new material, but it's one of those, okay, well, do we just keep using this technology, or do we switch over on some of the stuff? But rather than try to get a drilling rig out there and an air package and all that stuff, this is the route we're going right now because economically it makes more sense at the moment. One of the things that we did run into when we air drilled these wells was we ended up creating a lot of drilling damage. All the fines that get generated obviously from drilling with hammer bits and an air package that's flowing millions a day, just trying to lift cuttings and all that stuff, we ended up creating a lot of near wellbore damage that we had to go remediate after the fact, which we were hoping wasn't going to be that bad, but it ended up being an issue. And so this is also a nice bonus with what we're doing right now moving forward, because if we can do everything on fluid, then we don't have to use the air package going forward. And I'll get into that a little bit as far as what happened and why we originally went on air here in a second. But we have all 5 wells that we've drilled so far and have encountered gas. Now, the thing that has changed, though, is the first wells we drilled, which was based off of an initial discovery well that was done by one of these mineral coring rigs that blew out. They were drilling a well, weren't watching their fluid, lost all their hydrostatic, and the well came back to see them. Well, when we drilled the offset to that, we thought, oh, we're dealing with an underpressure reservoir, because we thought when the fluid hit the productive reservoir, that's where they lost it all. And Okay, so, and when we drilled the Jetstream 1, we had about 200 pounds bottom hole pressure. That was it. And so it was like, okay, well, this makes sense. Here's what happened. They lost all their fluid in these fractures, and that's why the well blew out on them. And so that's why we went with the air packages first. Well, when we started drilling the next wells with the coring rig, we're like, okay, well, let's see how we can mitigate this with fluid. Hopefully we won't lose returns. We've got a few more tricks up our sleeve. Most of these core drillers are used to drilling in these conditions, and they've got some techniques and stuff like that. And come to find out, on the last 3 wells that we've drilled, we're actually seeing reservoir pressures that are slightly overpressured. So it looks like we are not as underpressured as we thought we might be, even though that was going to be fine. I mean, we know Hugonin's a highly underpressured field. That's been not an issue, but it completely changed what we thought we were dealing with, especially from a resource assessment. But that in and of itself is going to make operations even that much easier moving forward, because now we can really employ just normal techniques. We just have to be careful about what we're seeing, what we're getting into, because even with pressure, I mean, a fracture can take fluid pretty quickly. It's not like, you're dealing with matrix. So just operational stuff that you get going forward, and has made my life a bit of a challenge on analysis, because I thought I was dealing with under pressure, and now I'm dealing with normal to overpressure, but that's actually a good thing. So we do have some infrastructure in place, thankfully, already. We don't have pipelines yet or gathering systems, but we are near rail lines, and we are also near shipping ports. We're not that far from Duluth Superior on the Great Lakes, so we can if we can get stuff there, we can get it going quickly to where we need to go. We do have an agreement right now with Chart Industry to help us build our facilities, but of course that now is going to start changing with some of the stuff we've seen going forward, because all the pressures have changed going forward. But that's okay. The biggest challenge we're going to have is, and I'll show you this when we get to the gas analysis, is what do we do with the products? Because we're mainly going to be dealing with CO2 and helium, and I'll talk about that here in a second. The regulatory situation is extremely challenging. That's the nicest way I can put it. You're dealing with a state that has no concept of oil and gas, and honestly hates oil and gas. So even though you're not dealing with hydrocarbons and evil oil and gas companies, they do not know what to do, even though there's how many states that have had oil and gas regs for decades. And the initial set of regulations that they came out with, even though their support, were more onerous than dealing with the Bureau of Land Management. So a lot of us have dealt with BLM before, and that can be a bit of a task and a challenge, but they were even worse. So we're trying to work with them. We're trying to get some things going moving forward. Thankfully, we do have a lot of local support. We have legislative support. The issue right now is getting things through the bureaucracy and honestly through the governor's office. That's going to be a huge challenge going forward. Regardless of where you fall down on issues, the Walz administration is in some difficulties right now with all the stuff that's going on there. So this is supposed to be presented as far as the new regs in this next session, but whether he ends up getting to it or does something with it, who knows, because there's other stuff that he's going to be dealing with. But it'll be interesting to see what happens, and hopefully there'll be enough local pressure and things like that he'll sign it and push things through. The biggest thing we need right now from the state of Minnesota, because a lot of this land up here, you're dealing with local, tribal, federal, and state lands. So you're dealing with, and it's a complete hodgepodge of who owns what, who's where. So dealing with multiple entities as far as leasing is a challenge, and also getting other stuff through, like pipelines and gathering lines, is a challenge. But Minnesota right now at the state level does not have leasing terms. They are sitting on Governor Walz's desk right now and have been for months, which is a big piece that everybody's waiting to come to fruition, because we're not the only company who's up there looking not only for helium, but hydrogen's huge up there. There's a lot of companies that are looking for hydrogen plays. Well, until he signs off on the leasing stuff, everyone up there is kind of at a standstill from that standpoint. Hopefully a lot of this gets resolved in 26, but we'll see. But we do have right now, we do have about 65,000 acres leased up in the area. So at least we have a decent position. You know, it's not like we're sitting there with just a couple of sections. And we've actually, I can't remember if this slide's coming up, we actually own some down here now. We just signed a deal with Quantum Hydrogen down in the Anamiki Basin, which is just the next layer down from the Bald Eagle intrusion. So when we drilled the Jetstream 1 last year, our actual peak helium concentration was 14.5, which is one of the highest concentrations that has been found worldwide. We did the analysis on the well and did a well test, did a bit flow, did a buildup, and based on what we were seeing, and this is basically in a 1-by-1 box, and I did the analysis on this one, and we were trying to be as conservative as possible, but you're looking at, you know, basically in a 640, about half a BCF, so 0.4 to be exact. So when you look at the pricing for helium and even for CO2, it doesn't take, I mean, you don't need much. So 400 million cubic feet of total gas, once you start separating that out, looks like it's going to be, you know, completely economic. Well, that was also based on 200 pounds bottom hole pressure. Well, now if we're dealing with wells that we're seeing even more than that, you know, these numbers are going to go up. And once we can start getting some additional flow tests, some additional buildups, you know, which will be coming up later this year, we'll see what happens with those numbers. So here are the results we've had to date as far as the wells that we've drilled. The Jetstream 1, we finished deepening it last year in about this time. After the clean out that we did in August, we saw a peak natural flow rate of about 500 million cubic feet a day. On compression, not 500 million, 500,000. So 500 MCF, let's just go back to oil and gas terms. On compression, we got this thing up to 1.3 million a day. And based on what we were seeing with the well, while the low pressure and there was somewhat of a decline, there was nothing really showing any boundaries or any massive decline at the moment. Time will tell on that once we can get some actual production and some drawdown tests, and we'll see. Then we drilled the Jetstream 2, and that well did not quite do what we hoped it would. We think there's a little bit of damage still, but it also looks like, I said, you know, that this is a fracture play. It looks like the orientation of the fractures is going to be probably one of the biggest drivers on what wells work and what wells don't. And the fracture network in the Jetstream 2 is different from the Jetstream 1. And so there's going to be a challenge to figure out going forward when we run into wells like that. Okay, maybe can you orient these wells into a preferential fracture plane and maybe get better production out of it that way. But the thing is, at least we did see production out of it. Helium content wasn't quite as high, but it was still a positive sign. And then we drilled the Jetstream 3, 4, and 5, and as you can see, you know, these pressures have jumped up quite a bit compared to what we were seeing on the initial wells out there. And all three of those wells were flowing not that they were blowouts, but, you know, on connections, we were getting gas flows on connections consistently. And so we had to do, you know, we just controlled everything with fluid, but it was nice to see that, you know, we weren't going to be completely dealing with an underpressured system and everything for now. The one question we have going forward is, right now, none of these wells are talking to each other. And I'll show you on a map how close a lot of these are. And this is going to be the next challenge we have going forward as far as trying to develop this play. But one thing I want to quickly talk about here is this is the gas that you're dealing with. So about 8% helium. Of course, the 2 is a little bit lower. We'll get the analysis on the next 3. But that 70% plus CO2 number. So we are trying to market the CO2. Obviously, you have enough. You can purify it to a pretty good industrial grade fairly easily. We are trying to get it to a food grade, but we are just a little bit above where we need to be on the parts per million to get that CO2 to go from 250 parts per million down to 50 parts per million to get it to food grade. But the good thing is we have a market for it. It's not a ton of CO2 that we have to get rid of and either sequester or do something with to dispose of it. So there is a revenue stream for it. So that's a definite positive, even with that much CO2. But the good thing about this is that with CO2, helium, and basically the rest of it nitrogen, and a tiny amount of methane, and even some other hydrocarbons, the processing on this gas stream is so much easier than it is if you're trying to extract helium out of a hydrocarbon stream. The plants can be much more efficient, much easier to operate, and it's not going to be the difficulty that you can with trying to just basically pull helium as a waste product almost out of a hydrocarbon stream. So much more efficient plants. We'll be able to liquefy all these products fairly easily, and which also increases their value doing it that way. So when we did flow the jet stream 1, going back to the test on that one, we did a clean out. We averaged about 200 a day over the test. Highest we got to was 500 a day, but the rate was still climbing at the end of the test when we shut it down. And one of the things I didn't quite realize you could run into from a production standpoint, so these, let me tell you, these wells make no water. They're completely dry. It's a gas stream only, that's it. But what's interesting, I did not realize that you could get basically a liquid loading effect with CO2. As the CO2, we would basically get waves of CO2 that come in as the gas is coming out of the reservoir, and since that's got a higher specific gravity than the helium, it would start suppressing our helium numbers until everything built up. And so you'd see a yo-yo on your helium versus your CO2 numbers on gas analysis. You'd also see your rate profile dip as well, which was an interesting phenomenon I never expected to see just in a pure gas stream, that you could have a heavier weighted gas that would influence, especially a light gas like helium is. So that's going to be an interesting production challenge moving forward. Of course, first brushes, I think tubing will fix that, but we'll see. But there again, there's the gas component that made up the jet stream 1. When we flowed the jet stream 2, like I said, we didn't quite get what we had hoped for. We still struggling to get inflow into the well. Peaked out at about 50 a day and averaged about 20. So we're not quite sure we're going to do that with that moving forward. Like I said, it may be just a preferential orientation when we actually drill the wells. So here is an additional map on, this is where our project is right now. This is a small town of Babbitt, Minnesota. Up here is the Edgewaters. There's the tourist town of Ely that's up there. And then here's the North Shore Iron Mine that's been around for decades. And most of this is U.S. Forest Service land, along with state land and then some private ownership in there. But then right here is a rail line that is available for us to go deliver product down to if we need to. We're just a few miles away from that. There's three-phase power also down there. There's, the road improvements will need to be made, but basically, everything is there for us. We're not completely in the middle of nowhere as far as delivering product and getting things to market. So here is how close these wells are together. So here's Jetstream 1, that was the initial well. Jetstream 2 was 650 feet away. Jetstream 4 is 800 feet away from Jetstream 1. You're about half a mile up to Jetstream 3 here, and then we're a mile, 1.8 miles over to Jetstream 5 over here. Right now, like I said, none of these wells are talking to each other. We have not seen any pressure communication between any of the wells. As we'll find out more here. We're going to be testing 3 of these wells probably at the beginning of February right now with the way things are going. So we'll see if that holds true, but nothing as we've drilled these wells, we've not seen any interaction, no response whatsoever as we've gone through them as far as pressure communication, even with some of these as in close proximity that they are. But the thing that's going to come out of that, though, and this is also going to be a challenge, we've done some 2D lines, we've done ANT, and so we've got some subsurface seismic information about the reservoir itself, but we really need 3D over the entire area. And with not having a regulatory framework in this area, you're dealing with an infrastructure system in the Minnesota state government that they really don't know how to handle this. And so you're looking at probably, it took us a year to permit a 2D line. And so you're looking at probably at least a year, if not 2 years, to permit a 3D project out here. Plus you have to deal with the state, with the Forest Service, with the tribes, and then private landowners. But it's going to be imperative, this project, because like I said before, with this being a volcanic area, we think a lot of the stuff may be compartmentalized. We don't know for sure. That's the working theory of a geologist right now, which may be why these wells aren't exactly talking to each other. So the trick you come up with that then is, okay, as you're drilling these wells, and honestly, we're drilling this stuff pretty much blind right now. I mean, our geologist is feeling pretty good that he's 5 for 5 at the moment for the most part on this. But I mean, you're drilling exploration wells that you really have no idea if you're going to hit or not hit at the moment. And so 3D is going to become hugely imperative moving forward, especially from a resource evaluation as a company, because you're going to have to explain to everybody, okay, here's how much we have, but here's where it's all located, especially because you're in a contiguous reservoir, but it's a busted up contiguous reservoir. So that's the next challenge moving forward as far as getting all of that going to try to get a bigger picture, but you're years out potentially with the regulatory framework. Again, this is more just a plug for Chart. We have been working with Chart Industries for a year now and helping with plant design and things like that. We have one of our investors has basically offered to help us fund the plant if we go with Chart, and so we're kind of leaning that way right now. But they do have some technology that is pretty much proprietary at the moment compared to some of the other processing plants out there at the moment, which is why Baker Hughes bought them. So that's the interesting thing we're dealing with right now as we get more information, try to get to Chart, to get a plant developed. Okay, now they're in the middle of a merger with Baker Hughes, and how's all that going to work out? Nobody knows. You know, of course, we all hear the wonderful happy talk on the street about, oh, it'll be fine, we're going to merge, it'll be great, and we're all working together. And so we'll see how that goes. But the idea is right now is we would cryo both streams, both the CO2 and the helium stream at the moment. And so they're working with us. Everything right now is based on the original gas analysis from the Jetstream 1, and we'll have more analysis to them probably by the end of March or so once we get testing done. So the plans moving forward, here's what we've done so far. This was most of 2025 as far as everything that we did with the drilling of the wells, getting listed on TSX. We got a lot of financing sorted out. We made the helium-3 discovery with the Jetstream gas analysis. We had the acquisition of Quantum and the additional acreage there. We've got the wells drilling. But going forward, we're going to finish drilling the wells we have right now. We're trying to keep that program going at the moment, one, because of the cost efficiency, but two, if everyone's seen the price of gold right now, if we let that rig go, it's gone, and it's going to go searching for some company for gold. And who knows when we'll ever get it back. But we're working on that. We're going to start shooting 2D at the end of this month. And we got the flow test coming up, some additional lab analysis. I'm excited to actually have core material so I can send it off and get fluid analysis done, which I've not been able to do. Those of you that know my history with completion fluids, I'm excited about that one because you're dealing with a system that has no water in it whatsoever. I'm always fearful about putting water in there. So what can we do to make sure we don't do any damage on these wells going forward? I've got a resource update to get done by the end of June, which I'm not excited about, but that's the way it goes when you have to do reservoir analysis. And then we'll have economic analysis and additional information from Chart as far as the facility design by then. More boring corporate stuff about the structure of the company, what the stock has been doing, things like that. This is our board of directors. I report to Tom. He's in Portugal. Neil's one of our chairmen. He's in Portugal as well. Dan is in Canada. Jan is in the UK. Doris is in Canada. And I think Bryce is he may be in France. But that's how spread out we are. And then, of course, I'm here. Nick is over in Scotland. Peter's in the US here with us. Cliff actually moved up to Minnesota for us. He's handling a lot of our contracts moving forward as far as the marketing. Steve Campbell, who is originally from here, went to OU. He is based out of Texas now, but he's been up in Minnesota quite a bit. And then Mark just moved from the UK over to Portugal. So then here's all of our contact information. And Here's a bunch of definitions and references, and that's it.